This is a little instructional video on how to um, use Geogebra in Moodle to answer these questions. So this is one question that's just chosen at random, and it kind of gives you directions, point A and B. We're going to use those to graph the graph. One of them has to be on the x-axis, um, and A has to be on the left and B has to be on the right. So the order can't change between A and B. Um, They're the first 2 points in graphing using a table for sine or cosine, and I'd highly suggest you do your work before you even try moving the points around. One of the easier things to do, of course, is make two decisions. The graph is cosine, and cosine does not start at the origin. And also the amplitude is 1. So the highest this graph is going to go is +1, the lowest is going to be -1. And positive cosine starts high. And what happens if I take both points off the x-axis is the graph disappears. So you have to put the other one back on the x-axis for the graph to reappear. All right, so this is a cosine of amplitude 1. And the next thing we have to figure out is there a phase shift? Am I going to move A left or right? And what is the period? And the distance between A and B is going to be based on the period. All right, so let's start doing the work to find out what the phase shift and the period is going to be and how to use that information to finish the graph. So let's start with the inside. So 3/4 x plus 7 pi over 16. I like putting the pi in the numerator. The program doesn't do it, but mathematically it looks prettier. And the period of a sine or cosine is 2 pi, and this of course is cosine. And we're going to solve for x. So we're going to subtract that across. So we get 3/4 x is equal to -7 pi over 16 plus 2 pi. And then I think the easiest way to deal with this is to multiply everything by 4/3. So we're going to get x is equal to 4/3, so this would be, I'm going to have to write it in so my brain can see it. The 4 will go into the 16 4 times. 4 times 3 is 12, so it'll be 7 pi over 12. And then 4/3 times 2 pi is going to be 8 pi over 3. Alright, so this part is the phase, and that's where you're going to move the A to, because the A is the beginning of your graph, and you're going to phase it -7 pi over 12. Now, two things. This information is going to go away for just a second. I have to move A 7 units to the right, and the reason it has to go 7 of these dashes is each one of these dashes is pi over 12. If we got out to pi over 2, that would be 1, 2, 3, 4, 5, 6 dashes. 6 pi over 12 is the same thing as pi over 2. So I need to go 7 of them, so A is going to have to come back here to this location. And then we're going to decide where B is going to go. So let me hide this for a second. I want to move A where it needs to go. It still has to stay 1 high, but I need it to go -7 pi over 12 to the left. So the negative is telling me to go to the left. Let's bring back my work. The period is 8 pi over 3, so this is the whole period. All I need, though, is from high to middle is 1/4 of our graph. So I'm going to take 8 pi over 3, and just like if we were going to do a table, I would multiply it by 1/4, and that would become 2 pi over 3. And again, this thing is marked off in 12s, so I need to change it into pi's over 12. So I need to multiply top and bottom by 4. So this would be 8 pi over 12. So the distance between A and B has to be 8 of the tick marks, 8 pi over 12. All right, hide the work for a second. So let's see, this was 7 back, 8 would be 1 more, so B has to go right there. So we have a cosine graph. The phase shift was -7 pi over 12. The period was 8 pi over 3. And if we multiply top and bottom by 4 there, that would be 32 pi over 12. So it would have to be 32 units all the way to here. Or is it here? Here. So if you want, you can count from A to here, and that should be 32 pi over 12. But we only need a quarter of it. So we're only going to do the 8 pi over 12, which is to here. All right, and then just hit check, and it should, I hope, graph is all correct. So it'll tell you all the pieces that are correct, and if it doesn't have a piece that's correct, it will not say graph is all correct. So if your base graph is incorrect, this would not show up. If your amplitude and orientation are not right, this would not show up. If your period wasn't right, if your phase shift wasn't right. The only time that this one shows up is everything is correct. And that's how you answer one of these questions. You do your work first, off to the side, and you use that information to plot it in GeoGebra.